Dear ladies and gentlemen, this is my solution to the Check24 GenDev challenge for home widgets. So first of all, I'll show a very short demo. So we have right here this whole front end, and as we can see that we have already a few of them, the widgets built already, and this management tab is absolutely not supposed to be there because the widget logic should be handled by each decentralized service team, product team. But in this case, we just want to make sure that it is pretty easy to use and easy to demonstrate. So we just use a simple management tab to mock that logic. So as we can see that we just create a few widgets. However, in this home field, we can only see that there are only 5 of them displaying, and this is because of the priority logic. So this logic is here because we want to make sure that we have a correct business logic for the ordering, or also like to display the most important, most relevant widgets that are supposed to be shown to the users. So this here priority, what I use is a random number, but however, in real case, the Check24 team should implement the rendering logic based on their own business logic or algorithm. And another thing to mention here is that we have 2 users. Normally, it should be a lot of users, like all Check24 accounts or customers. However, here it's just for demonstration purposes. We can see we go to user 2, it's completely empty. Or we create a few, it's a completely different set of widgets that we display. That means that the personalization of this application is there. One more thing to mention here is that we have a pre-built iOS app. So that we have this iOS app here, built using Swift. And if we refresh it, we can see that for user 1, for instance, they show the absolute same set of widgets. As we can see that this is basically because they are all connected to the same backend. So to explain this UML real quick, we have here a very normal architecture, a microservice architecture. Sorry, I can't open that very, okay, it's right now there. Every single product service are like implemented decentralized, just like Check24 in reality. However, all of them, they are connected to this home service backend so that they can emit or convey these widgets to the backend. So this basically acts like a API gateway, but also filtering and rendering logic of these widgets. So all these widgets are stored in this Redis cache. So why we use a Redis cache over another database is because we use event management system. So like each widget is not only a widget entry itself, but also an event, so that we can just simply like deletion or update these widgets are pretty easy, just a simple event emission. What's more, we have a time to live configuration for Redis. So like each event has time to live. So that's why like these widgets can just simply be deleted if they're not used anymore. And of course, we have this REST API that connected back into both front end. So it means that it works also with different front end services. So we have 6 requirements for this application, and we'll go through them one by one. So first one is high traffic with fresh data. As we can see in this architecture, the cache widgets are also stored only in Redis and also refreshing background. So everything is centralized, the whole logic centralized. Only emission of these widgets are handled by one independent services, which means that it can absolutely deal with high traffic and also fresh data. And the second point is that the flexibility and decentralization. And as we mentioned before, each service handle these widget logic and also the widget payload themselves. So it's completely independent from each other. So like Fluke service can absolutely implement their widgets differently as Handy Fatak service, just change the payload. And the third is personalization, and we showcase here already, is all handled by this home service backend. So it can filter out the user ID so that it can only display the widgets that's supposed to be shown to the specific user. And the fourth point is the cross-device consistency, and also it is showcased here. So like we have a simple common backend, and they're also distributed to both of them. So like both of them share the same backend, but also display the same thing. And the fifth is a performance versus conversion, and is also explained by this priority function here. And the sixth is the high availability by design. So if one service fails, it doesn't affect the whole system because it will always like just respond successfully. And one more thing to mention here is that this whole framework is deployed using can be both deployed using Kubernetes and also Docker. So we use a heads the VPS, so everything related is here already using a CI/CD pipeline. So thanks for listening.